So I like to start with a question. Okay, I like to start with a question. Can you see this? So this is a structure, right? And I'm applying a load P, as you can see, at the point D. Let me say this is of square cross section. You can assume it to be a square cross section, and let me say the area is the side is A. Now, can you tell me what is the stress at point M and what is the stress at point N? Anybody would like to try it? What is the stress at point M and what is the stress at point N? Well, how many of you feel that it is force divided by area, P by A? Is it P by A? Is it P by A? No, you're probably wondering, right? Most of you are wondering. It doesn't seems to be P by A, or you are at least not able to apply the concept. Okay? In today's lecture, we will try to learn a lot about this. Okay? How to calculate the stress at point M and N, right? Because of this force P. Now let us go through some questions which have been asked in GATE. Let us look at where exactly we will apply this question and why it is important. Right? Look at this question which was asked in GATE mechanical. We'll see two questions, right? And we'll try to justify, right, today's class. So this is a question which was asked in GATE mechanical. Can you see this question? Right? So there is a force F here acting here. The force F is acting here. The cross section is given. And you need to find what is the stress at point P. Quite similar to one, easy, seems to be much easier than what we have seen, right? What is the stress at point P? Do you feel it is force divided by area? Probably not, right? Probably not. Now let us go back to a problem. Now all of you are preparing for GATE AE, right? Aerospace. Let us go back to a problem, right, from an aircraft. Let us have the feel of this lecture. Let us begin with some feeling, right? Why exactly is this chapter important? And then we will go enter into the chapter. So this is a question from aircraft. So aircraft is landing. You can read the question, all of you. An aircraft is landing. At the time of landing, there is an impact load on the main wheel, which is of 22,500 G. Right, as you can see on both the wheels. And each wheel has a mass of 250 kg. Find the compression C and the bending moment M in the oleo strut. If the strut is vertical and 15 centimeter away from the center line of the wheel. So you can see this is the oleo strut. Most of you might be knowing it, and for those who don't know, okay, this is the oleo strut. And we need to find out what is the stress there, what is the compression, and what is the bending moment. So it is basically something like this. So and you have the wheel here. The wheel is here, right? And you can see the force is acting here. The force is acting at this point, right? And this is the oleo strut, and you need to find out what is the stress here in the oleo strut. It's quite similar to the problem which has been asked in GATE mechanical, don't you think? Right? The only difference is that here the force is in the downward direction, whereas here the force is in the upward direction. Otherwise, if you see, both the structures are quite similar, right? Let us look at a question which was asked in GATE AE, aerospace paper. You see, there is a 10 kilonewton force acting on a cross section which is 1 centimeter into 1 centimeter, right? And you are required to find out strains at these 2 points, 1 and 2. To find out strains, I have to find out stress. Can I say that what is the stress? Can I say the stress is equal to force by area here? Is it so? Because you see, there is only one force acting here. There is only one force acting here. There is only one force acting here, right? And it is 10. And all of us know that stress is nothing else but force divided by area. But you will understand in this chapter that this is not the correct formula to apply. This is just a part. And by the end of today's 1 hour, if you really pay attention in the next 1 hour, you will be able to, not completely solve, you will be able to partially understand how to solve this question. Because to solve this question, you will have to go at least 2-3 hours of class, which will do it. This is a question which was asked in GATE AE in the year 2016 or something like that. So let us start the class and let us try to decode all these questions, right? Let us try to decode all these questions, how to solve them. The name of the today's class is going to be loads, right? The chapter we are going to study today is known as loads. We are going to talk about loads, different types of loads and their effects. Let us start. Okay, I'm taking something from between, right? So that you can have an actual feel of how the classes are going to be. Let us take up this element. It could be any element. It could be any element, yeah? Cuboid element. Now I'd like you to tell me how many cross sections can this element have? How many cross sections can this element have? How many cross sections can this element have? 2? Well, the point is, there can be infinite cross sections for this element. I'm talking about cross sections. Okay, this is one of the cross section, right? If you want to take here, this is one of the cross section, but not necessary that this is the only cross section. But not necessary that this is the only cross section. How? You can also take up the cross section here if you want. You can also take up the cross section here. You can also take up the cross section here. It is up to you where you want to take up the cross section. My point. So this way, wherever you were cutting the member, you get a cross section. Wherever you are cutting the member, you get a cross section. So I can cut this member at infinite number of places. So there can be infinite number of cross sections, right? There can be infinite number of cross sections. Now, every cross section will have a centroid, right? So let me say this: the centroid of this cross section is this. The centroid of this cross section is this. The centroid of this cross section is this. The centroid of this cross section is this, and centroid of the last cross section is somewhere here. Every centroid will have, every cross section will have its own centroid. Can you tell me how many centroids would be there? Can I say there will be infinite number of centroids? Because we have infinite number of cross sections. Where you are cutting the element, you get a cross section there. Cross section is basically an area, right? Cross sectional area, right? You're crossing it. You're crossing it at a section, right? Cross section. So there are infinite cross sections. So if there are infinite cross sections, if I draw a line which is passing through all the centroids, if I draw a line which is passing through all the centroids, then this line is known as, this is a very major axis of the element, which is known as the longitudinal axis, which is known as the longitudinal axis of the member. Longitudinal axis of the member. Now, why we are understanding this? Because there are 4 different axes, which is very important to understand before we proceed. Okay, there are 4 different axes which are very important to understand to proceed. So what is the longitudinal axis? The longitudinal axis is the axis passing through all the centroids of the cross section. How many longitudinal axes a member will have? One element. This element has one longitudinal axis, as you can see. Okay. So longitudinal axis is the axis of the member. Now let us take up a cross section. Let me take up this cross section. Let me take up this cross section. The centroid of the cross section is this. The centroid of the cross section is this. Now I'm going to draw 3 lines, right? 3 axes for this cross section. All of you, please watch. This is one of the axes. This is one of the axes, and this is one of the axes. Can you see these 3 axes of the cross section? Let me say this axis is XX, this axis is YY, and this axis is Z. All these 3 axes are known as centroidal axis. What they are known as? Centroidal axis. Why? Because these are passing through the centroid. All 3 axes are passing through the centroid. So these are known as centroidal axis. Now you can see one of them is horizontal. The XX axis is horizontal. So its name is horizontal centroidal axis. One of them is YY. The YY axis is, you can see, vertical. And that is why it is known as vertical centroidal axis. And the third one, you can clearly see it is perpendicular to the cross section. The cross section I am focusing on. I am focusing on this cross section, and you can see the third axis is perpendicular to the cross section, and it is known as polar axis. It is very, very important to understand this axes if you really want to understand strength of material well. So there are 4 axes we have understood. The first one is the longitudinal axis, which is axis of the member. The second one is, the second 2 are XX and YY. These are horizontal and vertical centroidal axis. These are in the plane of cross section. These are parallel to the cross section, or you can say in the plane of cross section. And the final one, the Z, is the polar axis, which is perpendicular to the plane of cross section. This is perpendicular to the plane of cross section. Is it clear to all of you? Please type C if it is clear. Please type C in the chat box if it is clear. Now I know for most of you, it is the first class, demo class. You might not be very, very aware with the chat box, but we will conduct regular polls, right, to understand all this, to understand if you are able to capture the concepts properly. Great, fantastic, nice. So you've learned about these 4 cross sections. Now going ahead, I'm going to show you few forces. Okay, going ahead, I'm going to show you few forces, and these are very, very important forces. This is the first force. This is the first force. Let me say this is P1. This is the second force. Let me say this is force P2. This is the third force. Let me say this is equal to P3. This is the fourth force. I'm going to show you a few forces. Don't worry, we are going to discuss all these forces are different. Their magnitude might be equal. P4. Let me say this is one more force, P5. I hope you have some pen and paper with you, because you will have to P6 and P7. So how many forces are there in total? How many forces you can see here? How many forces can you see here? Yes, guys. How many forces can you see here? There are 7 forces, right? There are 7 forces. Now, all these forces magnitude might be equal. Let me say 5 kilonewton or 10 kilonewton, whatever you want, right? P1, P2, P3, all the magnitude, let me say till P7, they are of 10 kilonewton. But if you apply these forces, the stress that will be produced on this element will be different for each force. The magnitude might be equal. Let me say 5 kilonewton, 5 kilonewton, 5 kilonewton, everything might be 5 kilonewton, right? But all of them are going to produce different stresses on this element. So first of all, we'll have to understand these forces, what these forces are, and then we have to decode, we have to see how these forces are producing stresses and what are those, how to calculate them. As you have seen, the questions, I've shown you 2 questions which are asked in GATE, right? If you really need to solve them, you need to understand these forces first. So let us start trying to understand these forces, right? Now these forces, I will call them loads. I'll call them load. I'll call these forces load, right? Various loads. So the loads can be divided into 2 parts. As you can see on the screen, the loads can be divided into 2 parts: normal loads and shear load. Normal load and shear load. Normal load and shear load. Right? What are normal loads? Normal loads are those loads which are perpendicular to the cross section. The loads which are perpendicular to the cross section. You can see there are so many loads here. The loads which are perpendicular to the cross section are called normal loads. Right? Mind you, these are not stress. These are loads. I'm talking about loads. Can you look at this diagram and tell me which of the following forces, 7 forces, are normal loads? Normal loads are those loads which are perpendicular to the cross section. Can you look at the cross section? Can you look at these loads and tell me which of them are normal loads? Can you look at can you look at this and tell me which of them are normal loads? Yes. What are normal loads? Normal loads are loads which are perpendicular to the cross section. So if you look at these, out of all the 7 loads, can you see that what is P1? Is it perpendicular or parallel to cross section? Perpendicular. What is P2? P1, P2, P3. Can you see that these 3 loads are perpendicular to the cross section? Please type Y for yes, N for no. Can you see that P1, P2, P3 are perpendicular to the cross section, right? So P1, P2, P3 are going to be normal loads. What are P1, P2, P3? They're going to be normal loads. P1, P2, P3. Why? Because they're perpendicular to the cross section. What are shear loads? Shear loads are those loads which are parallel to the cross section. My dear, engineering is all about visualization. If you're able to, you have to learn to visualize. Can you see? P4, P5, P6, P7, they are parallel to this cross section. Yes or no? All these loads P4, P5, P6, P7, they are parallel to the cross section. Yes or no? Yes. So this P4, P5, P6, P7 are shear loads. These are all shear loads. So loads, the first division is normal and shear. Those loads which are perpendicular to the cross section are normal loads. Those loads which are parallel to the cross section are shear loads. Right? Now, normal loads can again be divided into 2 parts: axial loads, eccentric axial loads. What are axial loads? Axial loads are those normal loads, means first of all they must be perpendicular to the cross section, right? And are also passing through the centroid. Those normal loads which are passing through the centroid are known as axial loads. Which of the following is an axial load? Can you see? Which of the following are axial loads? Normal, that is perpendicular to the cross section, as well as passing through the centroid. Yes, guys, can you see? P1, very nice. You can see P1, P2, P3 are normal loads, and out of this, only P1 is passing through the centroid. Only P1 is passing through the centroid, right? So P1 is going to be an axial load. right? P1 is going to be an axial load. If the normal load, right, means they're perpendicular to the cross section, but they're not passing through the centroid. They're not passing through the centroid. They'll be known as eccentric axial load, EAL. Eccentric means not through the center. It is away from the center. Right? So look at this and tell me which of the following loads are eccentric axial loads, EAL. That is perpendicular to the cross section, but not passing through the centroid. Can you figure it out? I really love if some more of you can interact, right? Otherwise, you'll make me fall sleepy. Come on, guys. P2 and P3. Can you see this? P2 and P3 are normal loads, but they are not passing through the centroids. One is above the centroid, the other one is below the centroid. So they are going to be eccentric axial loads. Now, why we are studying this? Again, let me go through you. All these loads will produce different effect on the material. Right? They will produce different stress, and we will do it in class. We'll do all different loads, and we'll see which load, if it acts, and how is it going to produce different stresses. Let us look at shear loads. Shear loads are those loads which are parallel to the cross section. If they are passing through the centroid, they will be known as transverse shear load. However, if they are not passing through the centroid, they will be known as eccentric transverse shear load, ETSL. Let us focus on the TSL first, transverse shear load. What is transverse shear load? Parallel to the cross section and passing through the centroid. Can you look at this diagram and tell me which of the following are transverse shear load? Can you look at this and tell me which of the following are transverse shear load? P4, very nice. There is one more. Can you find it out? P6, fantastic, fantastic. P4 and P6. So P4 and P6, these are the parallel to the cross section. At the same time, you can see they are also passing through the centroid. So they are going to be transverse shear load, TSL, right? Which one? P4 and P6, right? 4 and 6. Now, which of the following are not passing through the centroid? Shear load, right? But not passing through the centroid. Shear load, but not passing through the centroid means ETSL, eccentric transverse shear load. Can you look at it and tell me which of them are ETSL? Which of them are ETSL? They are shear, but not passing through the centroid, away from the centroid. Very nice, Sanjay, fantastic. P5 and P7. I'll definitely love if more can interact. This is how you learn, right? This is how we learn more. So P5, right, and P7, right? These are eccentric transverse shear load, ETSL. Now let me give you a brief, right, understanding how these forces have different effects, right? Now, axial load will only produce tension or compression. If the load is acting as axial, we'll see this. We will have a complete module on this axial loads, right? We'll solve all different gate equations. For axial loads, you can give the stress as force divided by area. It will only produce what? It is going to produce tension or compression. It is tension or compression. We'll see this. We'll discuss. We will open up everything and we'll see it in class. So if the loads are axial loads, then you can give stress is equal to force by area, and it will produce either tension or compression depending on which side the force is acting. Means if it is only P1 acting, then you can say the stress in this member is going to be P1 divided by A, but not for any other loads. How? Let us have an example. Let us try to understand it. Eccentric axial load. Now, eccentric axial load, if you apply an eccentric axial load, it will produce tension or compression, plus it will also produce bending. It will also produce bending stress. Let me give you an example. How many of you have tried to put in a nail into an wood or into the wall using a hammer? Have you tried? Yes, guys. Have you ever tried putting a nail into an wood or wall using a hammer? Yes or no? Yes or no? Why for yes and for no? Come on. I know all of you must have, right? You must have tried to put the nail using a hammer. Now, what is the most irritating thing when you're trying to do this? What is the most irritating thing? when you are trying to nail something, right? One of the most irritating thing. Till you are hitting the hammer exactly at the center, definitely the nail will go inside very perfectly. Till you are hitting the hammer exactly at the center, it will go in perfectly. What will happen if you move the ladder a little bit? If you are not able to hit the hammer, if you're not able to hit the hammer exactly at the midpoint, what is going to happen? What happens? Yes, the nail bends. Yes or no? Yes or no? Have you witnessed this? Right? Why is it so? Because when you are applying the force at the center, you are actually applying an axial load. So what is being produced is either tension or compression. Now in this case, you're hammering, so only compressive force, and the nail is getting inside. The moment you apply the force little bit away from the center, it is no longer an axial load AL, it becomes an eccentric axial load EAL. So along with compression, it will also produce bending, right? And that bending moment, it actually bends the nail. The bending moment, it actually bends the nail. Getting my point? You see how deeply strength of material is actually inside our day-to-day life. We sometimes fail to notice it. Similarly, let us try to see what is the different effect produced by eccentric transverse shear load and TSL and ETSL. Right? Now let me say you have a bolt. Okay. Let me say you have a hexagonal bolt and you want to open it. Okay. You have an hexagonal bolt and you want to open it. Okay. You have an hexagonal bolt and you want nut or bolt, whatever you want. You have to open it. So what to do? Where to apply the force? If I apply the force here, will it open? If I apply the force here, will it open? No, I know, right? If I apply the force at the center, axial force, will it open? No, definitely not. What I'll have to do? How to open this bolt now? I'll have to use a wrench. What I'll have to use I'll have to use a wrench, right? Now, using a wrench, you are applying the force here. Now, if you're applying the same force here, P here, it is not going to open, right? But if you shift this force little bit farther away, right? Now, you'll be able to open the bolt or the nut, whatever you are trying to, right? So what is the difference? Can you see that the magnitude of the force might be same, P, right? But the effect is different. Now, if this is the force, you can see this is an TSL. Why? Because it is parallel to the bolt cross section, right? And it is also passing through the centroid. It is parallel to the bolt cross section and also passing through the centroid. So this is a TSL. TSL cannot open it. But at the same time, if you're applying here, it simply becomes an ETSL because it is not passing through the centroid. It is still a shear load because parallel to the cross section, right? It is parallel to the cross section of the bolt, but away from the center. So this becomes an ETSL. So you are able to open the bolt. I'm just giving you an example from our practical scenario so that you're able to take it in the concept. The concept that I'm trying to deliver is that though all these loads P1, P2, P3, P4, P5, P6, P7, right? Though their magnitude might be same, but every force is going to produce a different stress in the material. We have to understand each and everything, right? We'll have to understand each and everything, right? Let us try to solve a small problem here. Okay, we will not go deep. Let us try to see. Okay, or let us go back here. Okay, instead, let us go back here. Did you see this? Let us go back here. Let us try to figure out what is P for the member AB. Now, initially, I asked you what is the stress at point M and what is the stress at point N, right? This was the question. What was the stress at point M and what is the stress at point N? We'll solve this question. We'll try to understand. You will not be able to understand each and every concept because it is difficult to explain everything in just within 1 hour, but I'll try to see. Now look at point P and can you tell me for the member AB, what kind of load is this? For the member AB, is it a axial load? There are 4 options. We have 4 options. It can be an axial load. It can be an eccentric axial load. It can be a transverse shear load. It can be an eccentric transverse shear load. Can you guys tell me? Visualize. Try to visualize. Try to visualize. I'll help you. Don't worry. Normal load and axial load. Definitely normal load. Is it axial or is it eccentric axial? Let us try to visualize. Let us try to visualize. Okay. Let me draw a little 3D member. Initially, yes, you will take some time, but with practice, you will definitely be able to come up. So this is the member AB. I'm not drawing all. I'm just drawing the member AB, and it is fixed from this side. What I'm drawing is the member AB. And where is the force P acting? Force P is acting somewhere here on the member CD, isn't it? You can see the force P is acting here on the member CD. So with respect to AB, right? If I want to see with respect to AB, so this is how it is going to look like. Am I right? Am I right? Yes or no? Now can you tell me what kind of load is this? Is it a axial load AL, or an eccentric axial load EAL, or a transverse shear load ESL, or an eccentric transverse shear load? Yes, I'll not complicate the drawing here completely. Yes, guys, come on. Can you tell me? Now, can you see if I draw the cross section? As I told you, right? You can take the cross section anywhere you want. Wherever you cross it, you get a cross section. Wherever you cross it, right, perpendicular to the length, you'll get a cross section. So let me draw the cross section. Might be then it gets a little bit easier for you. Let me draw the cross section. Right. So the cross section is somewhere here. Can you now tell me what it looks like? Is it perpendicular to the cross section or parallel to the cross section? Is it perpendicular to the cross section or parallel to the cross section? First tell me that. This is how the cross section will look like if you bring it just in near to P. We'll go step by step. We'll go step by step. Now tell me, is it perpendicular to the cross section or parallel to the cross section? Can you visualize? So let me sift the load a little bit. Then you might be able to tell. I'm sifting the load a little bit here. Now can you tell me, is it perpendicular or parallel? Is it perpendicular or parallel? Can you see it now? I sifted the load to help you visualize. It is perpendicular, right? Parallel would be something like this, right? It is perpendicular to the cross section, right? Yes or no? Y for yes, and for no. Did you understood that it is perpendicular to the cross section? Yes or no? All of you? Satish, Aditya, great. Now, is it passing through the centroid? Is it passing through the centroid? It's perpendicular to the cross section. Means it is a normal load, right? Is it passing through the centroid? Y for yes and for no. Centroid is out here. The load is out here, right? The centroid is here. The load is here. So it is not passing through the centroid. It is not passing through the centroid, right? Let us go back to our point and see if it is a normal load, right, but not passing through the centroid. It is what is it? It is an eccentric axial load. It is an eccentric axial load. Getting my point, all of you? So the load P is an eccentric axial load for the member AB. Now I'm going a little bit deep. Okay? Now everybody can do good while explaining simple stress and strain, and that is something you have learned it for so many times, isn't it? So what is the point? What is the point of again teaching you simple stress and strain, right? I will teach you definitely in our course, then it will start from there, right? But I'm taking something from the middle. I'm bringing something from the middle, and then you will get the actual feel how exactly the classes will be conducted. Then you will be able to understand the classes. Otherwise, the first classes, everybody can do good in the first class, right? It's so very easy. So this is eccentric axial load for the member AB. Is this clear to all of you? Let us see if you can answer me in the poll. So load P is an eccentric axial load for AB. Is it clear to all of you? Try to use the chat. Try to use the poll. I know most of you will find it difficult initially, figuring out each and everything. Very nice. Fantastic. Satish, Surveys, Irfan, some of you. So you have understood that it is EAL for the member AB. Now let us try to see. Okay. Basically, shall I go deep, or you want to just stay at a surface today? Do you want to go deep? Little bit deep? Shall we? Y for yes and for no. We still have few minutes left, 15 minutes. Shall we? Okay. Some of you might be actually doing this for the first time. Okay. It takes time, no doubt. Let us make it a little bit deep. Okay. Let us do it a little bit deep. Okay. So that you appreciate. Okay. You appreciate the class. So how to solve this kind of problem? Okay, how to solve this kind of problem, right? So this is the force P here, right? And I need to find out what the stress in the member. Right? Now for convenience, what I'm doing, I'm drawing a 2D diagram. Okay? Now since you have already understood that it is an eccentric axial load, let me draw a 2D diagram. So one force is P here. Let us go a little bit deep. Okay, I'm taking you deep into the ocean on the first class, demo class itself. Pardon me if I'm not, if it is a little bit harsh on you. Okay. This is the force P. Now, how to solve this kind of problem? How to solve this kind of problem? Now, to solve this kind of problem, we are going to use a technique, right, which is known as the dummy load technique. Right? What we are going to do is we are going to apply two loads, two equal and opposite loads on this member. In class, we will understand each and everything in detail. Don't worry. Okay? We'll understand each and everything in detail. Why each and everything. So P and P. These are two dummy loads. What are these? These are dummy loads. What is the meaning of dummy? Means they are not existent. We are using this technique to solve it. Actually, they are not acting. Dummy loads. Anyways, I'm applying this to dummy loads at the same point. So they will cancel each other. Then overall effect will be 0. Right? Overall effect of these two loads will be 0. Why? Because they're acting at the same point in the opposite direction. They will simply cancel each other. Right? So there is no other effect going to happen. But what you will see here is what exactly is happening in the member. What you're going to see here is what exactly is happening in the member. Now, all of you focus clearly. All of you focus clearly, right? Now, take up this load and this load. Can you see this two loads? Can you see these two loads? One is acting in this direction and one is acting in this direction. Can you tell me what is this? Can you tell me what is this? Anybody who can tell me what is this? Not shear load. Two loads, we'll learn about this in class. Okay, I'm going a little bit brief here. Two loads, equal and opposite, separated by some distance and acting on the same plane. This is known as a couple. What is it known as? It is known as couple. So if this loads act, it will produce a couple and the magnitude will be given by the bending moment M. The magnitude will be given by the bending moment M. Don't worry, we'll talk. We have a full class on this. We understand in detail very nicely. But I'm taking a little bit deep. Don't be scared. So you see, these two loads, this force P and this force P, right? I can actually replace these two forces. I can replace these two forces with a bending couple whose bending moment is going to be M. Okay, we'll discuss how to calculate the bending moment. So clearly, can you see this? Can you see this? What I have done? This thing, this load, one load acting here, it can be seen as like this. One axial load and one bending couple. One axial load and one bending couple. What will the axial load do? Let us calculate the stress at this point. Let me say point 1. Stress at point 1. Can you tell me, is it tension or compression? Yes, guys. Can you tell me, is it tension or compression? Can you tell me, is it tension or compression? T for tension, C for compression. Come on. This force, only the P force. This force, only the P force. Is it tension or compression? Very nice. It is tension. It is pulling the member, isn't it? Very nice. So what is the stress because of this? Plus the force divided by the cross-sectional area A. Force divided by the cross-sectional area A, right? And this is what is known as bending. We'll see this in detail. We have an entire lecture on this. Okay? I'm just giving you a glimpse here. Now, when the bending happens, this is known as sagging. It will bend this way, right? And when it bends this way, the stress at this point will be minus M by Z, where M is known as M is the bending moment and Z is the section modulus. So at point 1, we already have a tensile force, then we have minus M divided by Z. And what is Z? It is known as section modulus. We are going to learn it in detail. Now, why I'm telling you this? This is something you will learn in class. This is something you learn in class, right? So I just tried to complete the loop, right? Let us go back to our first initial lecture. Let me see how many of you have been able to understand. Okay, did you really get a glimpse, right? So here, the stress at point M will be written as force divided by area minus M by Z. We solved this question in class, and stress at point N will be is equal to P divided by A plus M by Z. We'll learn everything, don't worry. Okay? We are going to learn everything, right? But I'm just giving you a glimpse. I don't want it to keep it open because I started with this question. I have told you, right? So you see the force P, what it is producing here, the stresses. It is not equal to P by A. It is not equal to P by A. I don't expect everything to be clear, but let me see how many of you have been able to feel. Did you really get a feel of what exactly is happening here? Now I'll go back to that aircraft problem again. Did you get a feel what exactly is happening here? Why the load P is different? Let me see how many of you got a feel. Not much. So you see, there is a lot to understand. Okay? There is a lot to understand here. Okay? everything is done. We dedicate in about 50 hours, more than 200 questions will be solved in class. Right? More than 200 questions will be solved in class. More than 50 hours of class will be done. Separate doubt classes will be there. And you'll be able to solve this kind of questions very, very easily. That is a guarantee. You'll be able to solve this kind of questions very, very easily. Now let us go back to the question which was asked in GATE. Okay? Let us see. Okay? Let us go back to, this is a question which was asked in GATE A. Right? You can see this is a similar kind of question. Now can you tell me what is this 10 kilonewton? What is this force? Is it an axial load? Is it an eccentric axial load? Is it an transverse shear load? Is it an eccentric transverse shear load? Can you tell me by looking at it? Come on guys, you can do it. I know you are smart. Fantastic. Within 45 minutes you have really learned a lot. Really impressed guys. You didn't expect that you will be able to do it. This is an EAL, eccentric axial load, right? So if it is EAL, the stresses at these 2 points, how can I write it? How will I have to write it? E1 and E2. We just learned it now. Okay? It can be replaced by what? We can actually replace it by, to solve this question, what we'll have to do, we'll have to replace it using 2 dummy loads. I'll show you how to apply these 2 dummy loads and we'll understand it once again. Okay? Don't worry, this is a question which was asked in GATE AE. We do it in class in great detail. Okay? So we'll apply 2 dummy loads, right? 10 and 10. Again, I'm saying you dummy load. This is just a method to solve. Actual loads are not being applied. This is theoretical matter. On paper, we do it so that we can see, right, what is happening. Now look at this. This is a 10. This is a 10. 2 equal loads, opposite in direction, separated by some distance E and acting on the same plate. What it is going to do, it is going to produce a couple. And what will be the magnitude of the couple? Magnitude of the couple can be given by 10 into E. You will understand this. What is remaining? Remaining is this 10 Newton. What is remaining is this 10 Newton, which is an axial load. So what is the stress at point 1? What is the stress at point 1? The stress at point 1 can be given by, because of the axial load, 10 divided by area. Let us not completely solve it now. It will be too harsh on you guys to do so much in just one class. But I'm really impressed that you have been able to understand. It is P by A, that is 10 divided by area, plus, here it is going to be plus because this is plus M by Z, right? What is the stress at point 2? P by A minus M by Z, right? And we all know E1 by E2 can be written as sigma 1 by sigma 2, right? We can substitute these values. The values of E1 and E2 are given in the equation, right? And then we can easily solve it. We can easily solve it. I'm just giving you a glimpse. Okay? I hope it is not too harsh on all of you. Okay? Similarly, we can also solve this question. Can you tell me what is this force F for the member AB? Let me say this is AB. Can you figure it out? Can you figure it out? Can you figure it out? What is this force F on the member AB? It is an eccentric axial load. Don't worry. We will train our eyes because we have problems. I'll show you. We'll do detailed problems. For example, we'll solve it in class. We have this matrix. We'll see there are 3 loads acting on this member. We'll try to figure out P is what for AB, P is what for BC, P is what for CD, right? QR. There are 3 forces, and you'll be able to figure out. Okay. For now, as we are running short of time, I'll just let you know. This is again an eccentric axial load. Right? The stress at point P can be given by the force F divided by the cross-sectional area A plus bending moment M divided by Z. Right? Z can be calculated using this, right? ZNA, right? And the bending moment is going to be F into L by L minus B, and using that we can calculate it. And if you understood this, you can also calculate the bending moment at the strut of the aircraft. The force P here, this is again same kind of question. Okay? It is again the same kind of question. You can see what will be the effect of force P on the strut. There will be 2 things that will be produced. One is the compression C and one is a bending moment M. As you can see, that has been asked. Finding what is the compression and what is the bending moment in the oleo strut, right? So we have seen how to do this. The force P, again, we are going to apply to dummy loads and we will be able to find out what is the compression C, right? Compression C will be given by P by A, and what is the bending moment, right? And then we can calculate the bending stress also, which will be given by M divided by Z. We'll be able to do it, right? So thank you all of you. I hope you got a glimpse. The classes that are conducted are not just basic level classes, right? And you had a glimpse of what exactly will be done, right? To the length, to the breadth to the depth that you will learn in the classes. That is something I just wanted to give you. Just a trailer, right? This is just a trailer of what you are going to learn in our classes. Any questions? Any questions you want to ask? Was it a bit harsh on you all guys? Too much of information at a very short period of time? I just wanted everybody benefits. Whoever has seen it. Sunday seeing all clear. Fantastic. I really am impressed by you guys. Doing quite good. These are some of the toughest questions that are asked in GATE, and you have been able to understand them. But there is a long way to go, right? There is a long way to go because we have dedicated entire chapters to learn to how to solve this problem. We'll have to go through a lot of chapters, lot of understanding, so that you can understand each and everything from very, very basics, so that not even an iota of doubt is there in your mind. Any question, guys? Come on, you can ask me anything. You can ask me anything with respect to this, with respect to your preparation, with respect to anything that you want to ask. You can just get it clarified with respect to strength of materials. No? Yes, yes. Take your time.
Any doubt, guys? So, guys, all ready? Tomorrow we will have, we teach around 45 to 50 hours SOM. So first we will cover, guys, engineering mechanics around 25 hours, and then SOM will come. Okay then, guys. Thank you, sir. Thank you.
Okay.
All.
Thank you.
See you
Wish you all the
tomorrow, guys.
best. See you. Okay. Bye-bye.